So welcome back to water. We're looking at water pollutants that damage living things, including humans. This is probably the second to last screencast, and this topic is other water pollutants besides wastewater. There are three substances that pose very serious health threats to humans and to the environment, and those are lead, arsenic, and mercury. Lead is a heavy metal, and it's very dangerous to the neurological development of children. It causes them to have lower IQs and maybe even, good evidence also of behavioral issues. And the lead may be still found today in lead-lined pipes and in paint. So lead is a contaminant that was leached during the Flint water crisis, that was leached from these lead-lined pipes into neighborhoods, usually poorer neighborhoods, and children began to display high levels of lead in their blood. And so, as you may have heard before in the news, a pediatrician questioned why her patients were coming back with these high lead levels in their blood when that test is done. And so, actually, I'll go in more detail about Flint in a separate screencast so that we can make sure we can get through all of this. And I also have an activity that I'd like you to do related to lead. Okay, a second substance that's very serious for human health and the environment is arsenic. Arsenic is naturally occurring, but when mining is done, arsenic that might have been laced in the rock then becomes more concentrated as the mining occurs, and it increases the concentrations in both the tailings, those ponds that are used for the waste, and sometimes also getting into groundwater. So when it gets into groundwater that humans use for drinking, that poses a toxin for humans. When it's in these tailings, these ponds that are used for wastewater that results through the mining process, then that's something that organisms like birds drink from, and then they can die from that. Mercury is also very dangerous. Mercury is a heavy metal again. It's naturally occurring, but we add to it in the environment through coal burning and other human activities. And the problem with mercury is that it can be converted to a very toxic substance called methylmercury, and that can build up in fish and shellfish that humans consume. So just like we talked about with the DDT, mercury can biomagnify and bioaccumulate. So bioaccumulation means that mercury becomes stored in the fatty tissue of fish, and as the larger fish eat the smaller fish, the mercury that is stored in the fat tissue is passed on to the predator, and then it builds up over time into more concentrated quantities. So when you get to a very large fish, such as a tuna, that has very fatty tissues, then you can find very high levels of mercury. And that's dangerous to humans and toxic to humans and other organisms. So that's why if you've ever seen in the grocery store, there's light tuna and regular tuna. And if a person is pregnant, they're advised to limit the amount of tuna to a certain level so that they're not exposed to mercury or exposing the fetus to mercury. And the light tuna is literally light, and it's less fatty, and therefore it has less mercury in it. What mercury does to a human is very similar, but actually worse in some ways. It does affect the neurological systems of adults as well as children. And there was a phenomenon in Japan where people began to have this weird disease they called Minamata disease because it was taking place in Minamata in Japan. And people were, it was thought it was possibly a contagious disease because more and more people kept coming down with it. And it caused convulsions and shaking and people not being able to feed or drink handle food or drink on their own because they were convulsing so much. And it seemed to become worse over time and was definitely permanent. And they eventually determined that it was coming from a plant that was releasing mercury directly into the waterway. And the people of Minamata depended on fish quite highly for their food source, their protein source. And it was bioaccumulating and biomagnifying and caused this terrible disease. It took years, though, to get the company to admit to this and stop it from happening. I won't show you the videos because it's quite hard to watch, but if you want to look it up on your own, it's called Minamata disease and it was caused by mercury. Okay, world mercury production. More than half of it is produced in Asia. And so that's why you can see that things like this happened in places like Japan. That's just a little aside. Okay, so moving on from the heavy metals, another issue in water pollution is acid deposition and acid mine drainage. So acids, remember those are the low numbers on the pH scale. They come from things like burning coal, which results in sulfur dioxide and nitrogen dioxide being released into the air. Sulfur dioxide has an odor, that rotten egg odor that you may have smelled at some point in your life. I certainly did growing up in Baltimore. So the sulfur dioxide and the nitrogen dioxide that are released when coal is burned then are converted in the atmosphere into sulfuric acid and nitric acid. And then you can have two types of deposition: wet acid deposition, which occurs when rain falls down and this acidic rainwater is carried to the ground, or snow as well. And you can have dry acid deposition, where gases and particles in the air are affecting water, plants in particular, and soil. Both of these have very negative consequences. Also, along the lines of acid deposition, we have the abandoned mines, which create acid mine drainage. As water comes down, rain comes down, and it trickles through these abandoned mines. It picks up acids, which then it can be carried into the groundwater or into surface water, and again contaminate those areas. Okay, another form of pollution are synthetic organic compounds. Again, remember the term organic. Typically large molecules that are carbon-based and have hydrogens attached to them as well. Synthetic means human-made, not naturally existing. So synthetic organic compounds may enter water supplies from manufacturing or from placing these over large areas, such as they are some of the typical examples of synthetic organic compounds include pesticides, which might be spread over large non-point areas and then get into water bodies. So let's look at some of the examples of synthetic organic compounds. The first one is pesticides, DDT. What is a synthetic organic compound? And we previously looked at what that does. Pharmaceuticals are synthetic organic compounds. These are found now in about 50% of streams contain antibiotics and reproductive hormones, 80% contained non-prescription drugs, and 90% contained steroids. And how did those pharmaceuticals get into the water? Well, one way is through human waste. When you take a medication, it gets into your system, and some of that medication is produced in both urine and feces, and then it can get into the water despite the cleaning that goes on to remove any bacteria. It can't remove the pharmaceuticals, so that's getting into the water. A second way is people disposing of their pharmaceuticals by doing things like flushing them down the toilet when they're done with them. So instead of doing that, as you'll see when you do your waste lab, there are specific ways that unneeded medications can be disposed of properly so that they don't contaminate water bodies. Okay, another category are industrial cleaners. These are chemicals that are used in manufacturing, and we've greatly reduced the amount of this type of waste that can be legally dumped into a waterway. But back in the day, until basically 1970, many of these industrial cleaners did get dumped into waterways and are still containing them. So one of these famous industrial cleaners are PCBs, polychlorinated biphenyls. And these were used to make plastics and also to make insulating material for electrical transformers. They were banned all the way back in 1979 in the United States, but they are still present today. And there is direct evidence that these PCBs can cause cancer. So we don't want to see these in our water. Okay, some final water pollutants to look at. Solid waste. That means garbage. A tremendous amount of solid waste gets into waterways. Everything from plastic grocery bags to actual pieces of garbage have been found. And I think I've already talked a little bit about gyres, where the solid waste are circulating and get caught. They can be partially broken down, so they're not easy to see, but there are micro pieces like microplastics in the water that can be ingested by organisms such as fish. And there are whole bags, like grocery bags, that some sea turtles, for example, mistake for jellyfish and try to eat it, and it chokes them. And then they die from that. So solid waste is a problem that doesn't have to be. A second water pollutant here is sediment, and we often don't think about that, but that's sand, silt, and clay that enters a waterway, and you can see that in this picture. Usually it happens, though, on more areas that have been forested and the vegetation is cut down, or the area is overplowed, and then there's a lot of runoff that gets into the river, and then that carries it downstream, and you have this like fan of water pollutant. That's been a huge problem in places like Madagascar. If as a kid you watched that movie about Madagascar, it's a serious problem there. Okay, 3 more real quick. Thermal pollution. Thermal pollution means temperature pollution, making the water warmer than it normally is. This typically comes from water that's used for cooling, whether for a power plant or manufacturing. And some of that can be reduced, but it does change the biodiversity in the area that has been warmed. Noise is a problematic one. Noise interferes with many organisms, which we'll actually look at in a future chapter, but it can interfere with them, driving them away from an area, or even interfering with their communications with one another. And so noise is a possible issue. And last we have oil. I'm going to put oil on a separate slide, a separate screencast that will be very short.